In this video, we're going to see how to create protected user directories in Firebase Cloud Firestore, also known as Firebase Database. We have to remember a concept in Firebase Cloud Firestore, which is that collections and documents alternate, and we can use this to our advantage. So we start at the root, and then right after root, we have a collection, and this can be a collection of users. So this collection of users will point to a series of individual user objects, which are essentially documents. And then those documents can have collections themselves, and those collections could be something like our specimen object that we're dealing with in this project. And then those collections will point to individual specimen documents, and this process repeats. The specimens can have events, the events can have photos, so on and so forth. So we end up with this cascading style where we start at a root, then we have our users, and then so on and so forth. We can use this to our advantage because we can name each of those user documents after the user's unique identifier. And then we can write a series of rules in Firebase that restrict each of those directories to only that specific user. And that's what we're going to do in this project. So the steps that we need to consider. First, we need to set up Firebase authentication, which I've done in a previous video. Then we need to update our Firebase database rules, which I'll do in this video, in this series of videos. Then we need to create our user collection at root. We need to create a user data class that we can persist to that collection. Then we need to save our user object under each collection and save the user's data under that object. And then we can listen for changes at that user level. So in other words, I, as a unique user, will have a Firebase listener in my application that is only listening to my branch of that tree. It's not listening to other branches, so I'm not going to get notifications when somebody else's data changes, but only when my data changes. So with that, let's step in and take a look. I'm going to do each of these steps in a bit of a different order than I have on the screen. The reason being the rules will make a bit more sense after we have some objects saved. So I'll tell you what, let's start by creating the user data class, and then we're going to create the user collection at root in Firebase console. The user data class will be fairly straightforward. I'll simply put it under the DTO package. And we'll call it class user. We'll make it a data class, and we'll give it some attributes. We'll start with the simple user ID of type string, and it might feel a bit silly to have a data class with just one attribute, but this concept is one that we can expand over time. We can give it things like a subscription level, we can do things like check its access, we can give it other attributes like first name and last name. Let's start with this data class. In one step I'll take proactively. In my main activity, I have a Firebase user type stored in a variable named user. That's going to get confusing since I also have a data class called user. So I'm going to refactor and rename this to Firebase user, because I know I'm going to end up using my new data class user within this activity. I don't want to confuse those two concepts. Next, let's create our user collection. So we see here in Firebase Cloud Firestore, we have a collection called specimens, and we have a series of specimens from the previous videos that we've made. The problem is we don't know who these specimens belong to, which makes it hard to control access. We want to put our collection of users before our collection of specimens, and that way we can limit a user to his or her own collection and keep that separate or keep that partitioned off from every other user. We simply click Start Collection, and let's say Users. For the first document, let's give it an auto ID, and we know at this point we only have one attribute on that user class called UID, and that UID is actually going to store this document ID, but by putting it in the data class itself, or by putting it in this document, we then have access to that user ID on the Android environment in an easy way so that we can do updates and inserts and the like. And we save. Now under this we'll eventually make a collection of specimens for each user. We'll save that logic for just a moment. Right now let's consider how we can save a user object to Firebase and where we might want to do that. Well, remember one big advantage of Firebase authentication is that once we've logged on, we continue to stay logged on even if we close and reopen the app, unless we physically log off. And because this app doesn't really contain any sensitive information that needs any more protection than we already have on the phone with either a PIN or a swipe or biometric ID, I'm okay with leaving the user logged on to this application. So, as I mentioned in a previous video, we'll likely remove this logon button at some point after we finish testing. Nonetheless, that might be the first time that we meet a user, because if you recall when I did the logon, that's where I signed up for an account with my email address and my name and so on and so forth. So that would be a good time to save a user object to Firebase. So remember that we hear back from that sign-in in this sign-in result function. Let's take a look at the Firebase user object that we get back. It has several very helpful attributes on it that we can use. I saw one there, display name, which looks very interesting. There's also one UID. And guess what? That's that unique identifier, and that's what we need to create our user object. And actually looking at this, I'm thinking, why don't we go ahead and add display name to our user object as well? We'll start with what we have so far, which is this user ID, and I notice that it's telling me I have a type mismatch because Firebase user is nullable, and the user ID that I have in my user object is not a nullable type. We can fix this very easy with the let scoped function. Because we remember the way that Kotlin works. If we attempt to invoke a function on something that's null, it's not even going to bother invoking that function. It's just going to return null unless we give it an Elvis operator. And let is a function. So what we have within these brackets is essentially a lambda we're passing to let to tell let to run it. And it's only going to run that if Firebase user is not null. Now within this function, we see that the variable it refers to our parameter Firebase user. So I can simply replace Firebase user with it, and magic, the red line goes away without any need to do a force unwrap or anything like that. So a nice clean way to handle nullability. Now if Firebase user is null, no worries. We're just not going to walk through this logic. We might want to post some information to the user to say something went wrong, but we're going to skip over the logic that's in this block from line 285 to 287. So we'll start with that UID. Now let's go ahead and add it.displayName. And you see there are several other things that we can do from this Firebase user. We don't want to entirely repeat the Firebase user because that would be redundant, but we would like to have enough that we store in Firebase in this user's collection to know what user we're dealing with. Now, no surprise, this gives me a red line because my user data class, I have not told it about this second parameter yet, but that's an easy fix thanks to our IDE. I can say add parameter to constructor user. It is saying, well, it knows that I already have a UID. Now it's saying, hey, I have a hunch that the next parameter should be a display name. So I'm going to go ahead and refactor with one caveat. It didn't actually declare this display name in our constructor, so I'm going to go ahead and give it a var type, which means that it can be altered. And with that, the red line goes away and we can navigate back to our main activity. And red line goes away in our main activity as well. Now let's call a save function on our view model to persist this user to our users collection in Firebase. Once again, with one caveat, we have not made that function yet, but our IDE can help us out once again. So I pass in this user object to the save function that doesn't exist. In one moment, it should realize that the save function doesn't exist, and it should give me a red line. And on cue, there we go, Alt-Enter, create member function. And now we're in our main view model. And our main view model has access to Firebase, so this becomes easy to persist. We can borrow a bit of logic from our save specimen function up above with one caveat. In this case, we want to create a document with that user ID or UID parameter as the key. And we will already have that key based on the logic that we just implemented from the sign-on function. And so we'll want to use this second construction here, the Firestore collection.document section. And Firestore will know if it does not have a document with that key, it will create new. If it does have a document with that key, it will update existing. And so we do the logic like so. We access our collection of users. We access the document with this user's unique identifier, and then we essentially store that user associated with that unique identifier. Let's go ahead and save this to a handle, and then we can do our on success and on failure listener as we have up above. I've uninstalled the app from the emulator, so now we can deploy it to the emulator, and we can confirm that our logic works to this point. In other words, on first login, we'll confirm that we are able to save the user document to the user collection in Firebase Cloud Firestore. Now, we'll eventually want to do a bit of refactoring here. We'll probably get to that in a later video, but we want to confirm that we get the correct look and the correct data that we're looking for in Firebase Cloud Firestore. So I'll go ahead and debug. The app is loaded, so I'll click the Log On button, enter my user ID, password, and sign in. And now we're in the callback from our sign-in function, so let's watch our logic run here. We see that the Firebase user indeed is not null. And we can expand, and I find that the debugger doesn't give us a whole lot of information here, likely because it's something that's lazy loaded, but nonetheless, we can go ahead and step over and take a look at the user object that is created. And we see here that we have a unique ID. We'll remember just a few letters from this, V1JG8, so on and so forth. And display name, Brandon Jones. So you see we were able to get my name from the previous time that I logged on. Let's go ahead and tell it to continue. Now it picks up in our main view model. Just to confirm, there are no tricks up my sleeve. This document does not yet exist in Firebase Cloud Firestore. We simply have the initial user that we created. So we'll step over this one line at a time. We go back and we take a look at Firebase Cloud Firestore and take a look. We have a new document record with that unique identifier that we saw earlier, V1JG8, so on and so forth. And sure enough, we see the data from our user object that we created, display name Brandon Jones, and then that unique identifier. So we've confirmed at this point that we're able to store a user in this user collection. So at this point, we have our Firebase authentication, we have our user collection at root, we have our user data class, we save our user object under that collection, which leaves a few more things that we need to do. We need to start saving the user's data, which in our case is our specimen data, under that user's collection and then the user ID. And then we want to listen for changes on that path. Let's start with those, and then after those are finished, we'll go back and we'll update the Firebase rules. Let's start with a bit of refactoring. In our main view model, let's make a user variable, which is going to be an attribute. We'll initialize it to null, but then we will set it from our activity. So in our activity, instead of saying save user, let's start by assigning that user to our view model, and then change the function from save by passing in the parameter user to simply save user, like so. Back to our main view model, and we can rename that function here as well, save user, and then we will remove this parameter. Notice we are going to get some nullability issues here, so let's go ahead and use our let function to handle that nullability. And we're good. Reason we want to do that is we're going to have to do a bit more math on our listen to specimens. And we're going to need to set the user, whether the user's logging in for the first time or returning to the app after logging in. So that's why we want to make it an attribute of main view model. Let's go back now to our activity, and we've just handled the case where the user's logging in for the first time, because you see we're setting viewModel.user equals user. Now let's consider the case where the user is returning to the app after having logged in before. We'll handle that up here and on create. We know we're initializing our Firebase user up above, and we also know that this is a nullable type. So once again, we can use that let function to handle the not null and the null case. So here we have the not null case, and you notice what I'm doing is I'm constructing a new user object, when really what I should do is retrieve an existing user object from Firebase. I will refactor and do that later, but that would take about 5 minutes that I don't want to add to this video just yet. So I'll do that in a separate video. All we really need is this unique ID, and then we're passing that over to our view model. Now, what we could do is we could do our Elvis operator here, which means that if we reach this point, our Firebase user is null, and at that point we could prompt for logon. We simply need to invoke this sign-in function here. We could do that, but I don't want to do that, because that would force our user to log on the moment they open our app for the first time, which tends to dissuade users from using our app. That tends to be, I don't want to give you my personal information just yet. I want to explore. So I'm actually not going to bother with that. I'm going to not worry about the null ability. And what I will do eventually in a later video is I will force logon before the user can save a specimen. That way, we know that the user has logged on if the user has specimens. And if the user is null, well, then the user either does not have specimens or the user is accessing this app from a new device. So, it kind of narrows down the case a little bit. Either way, I'm comfortable at this point that I have set a user object into my main view model, and that user object is going to have that user ID attached to it. So now, when I'm listening to specimens, I don't need to go all the way up to the very root and look at the specimens collection, but instead, I can look at a collection that is specific to this user. We can amend our listen to specimen functions by saying firestore.collection users.document. Well, okay, now here we need to put that user ID, but we also know there is a possibility that we're going to be in this function and our user will not yet be set. So if the user is going to the app for the first time and has not logged in yet, we're not going to have a user ID, but then we're probably also not going to have any specimens. So there's going to be nothing to listen to. Nonetheless, we have to handle the null case, and well, guess what? We're getting a lot of practice with this now. How do we handle a null case in Kotlin? We'll take the object that might be null, which in this case is our user, question mark, period, and we invoke a let. Now, because I have a lot of scope functions going on here, I have a let down here, and I have a lot of things going on. The default name of the user variable within this let function is going to be IT, but let's rename it to user. It's very easy to do. We simply do user and then the arrow with the dash and the greater than symbol. And now within this block, we can refer to this not null user as user, and then we can refer to the attribute UID. I'll do a bit of indentation here as well since I've added another block. And save. Speaking of save, we need to update our save specimen function as well, because the save specimen function is currently saving these specimens at the root specimen collection. We need to change it to go to the user's collection, then our user ID, and then the specimens collection, and then save each individual specimen. Let's use a very similar construction to what we've just done. Now we'll borrow the logic from above where we go to the user's collection and then we look at this specific user ID. And we'll do that for both the create new specimen and update existing specimen. Let's redeploy and let's confirm that we are saving our specimens to the correct location. One interesting thing to note now that I've changed it to look at my user directory, I've essentially lost my old specimens. So in other words, in this dropdown where it used to show my specimens, there are not specimens anymore. So we'll start by creating a new specimen, and I've set a couple of breakpoints so that we can watch as it creates our new specimen. So I've added a few details here: flowering cherry, Washington Park, a beautiful spring bloomer, date planted March 2012, and now we'll choose save. We see it goes into save specimen. Let's confirm that our user is not null. Now, since I relaunched, it actually should pick this user up from a previous login. It's a little easier to see down here in the Variables tab, and we see that we do have this user identifier, which again is all we need at this point. We can refactor this to actually grab the actual user from Firebase, but at this point, we just need that user ID that we're getting from the Firebase user. And we can also see this is an object, so it is indeed not null. Let's go ahead and step over. Now, we're getting our document and adding our on success and on failure listeners. Now return to Firebase. I do need to click around a bit to get it to refresh, but take a look. We have a brand new collection called Specimens. And take a look under Specimens, and what do we have but something that looks familiar? We have a document ID we've not seen before, but we do see Flowering Cherry, Washington Park, a beautiful spring bloomer, March 2012. So you notice that this indeed has saved under my user document. We don't see it under the other user. We only see it under the user where I'm currently logged in. So effectively, we've now made a branch of this tree where I have data that's stored under my personal folder, and I can keep it separate from everybody else's folder. One other thing I'll likely need to refactor is I'll need to nudge it to listen to specimens again, because we see that I don't see the specimen in the dropdown. And if we go back and take a look at our main view model, we notice that it's invoking this listen to specimens in the init block. And at that point, the main activity has not yet received our user. So it gets to this listen to specimens and it says, well, I don't know who the user is. So I'm going to take that part out of the init block. I'm going to call it from main activity, which means I no longer want this function to be private. In main activity, when I have set the user, I want to go ahead and call listen to specimens. So we'll call it here. We could also call it from the logon down below. I'm kind of mixed on that one because, well, it depends on what's causing us to log in. If we're registering for the first time or if we are just on a new device. The reality is it doesn't matter. If we're registering for the first time, there won't be any specimens. If we are logging into a new device, there may be specimens. So there's no harm. Let me go ahead and call it from there. I redeploy the app and take a look. We have our specimen back. We had to do a bit of refactoring there, but now we know we're looking only at specimens that are in our user directory. So we have our Firebase authentication, we have our collection at root, we have our user data class. We save the user object for each user under that user collection. We save the user's data under that user's collection. We're listening to changes for each user on the same path. Actually, we're listening to changes to specimen. We still need to implement that part where we can actually retrieve the user object, but we'll worry about that in a future video. Let's just focus on getting our security rules wrapped up in this video. The last thing we need to do now, which hopefully will make a little more sense now that we see the structure of our data collection, is update our Firebase database rules. And trust me, Firebase hates when we leave our data wide open to read and writes, which is where we are now, and for good reason. We will eventually hit a limit where we'll need to start paying. Now, I've not yet hit that limit in doing these things for educational purposes, so it's not like you're going to be out a lot of money really quickly. But if someone were to get into your data store and store data there, it could cost you, but also consider if they were to store inappropriate data there. You certainly wouldn't want to deal with that. So it's a good idea to lock these things down. Let's just remember our structure here. We have users, and then under each user, we have a user ID, which matches that Firebase authentication ID, VIJG8. Under that, we have specimens. And then under that, we have each individual specimens, and we can continue to grow this. So remember again, VIJG8Z8, something like that. We go to authentication, we go to users, and we can see that user ID here, that matches perfectly. I designed it that way very much intentionally because that's going to make our rules much easier to write. Let's go to rules. And right now you see rules version 2, Service Cloud Firestore, match database documents. All of that is just fine. Match all documents. So within that all documents, allow read and write to anybody as long as the time is within 30 days of when I initially set up this database. So this is the part that we need to change. What we need to do is give users access only to their directory. And that's really simple. /users/ and then just like we would do in a RESTful service URL, we can parameterize the user ID. And that's that magic number, that jumbled kind of letter sequence that I showed you earlier. Now we can use that parameter down here in our rules. So let's change this to allow read, write, if request.auth, so that's our essentially request object, is not null, so we have something in it. And, watch this, request.auth. What's this? UID. Remember that UID equal user ID. And where does user ID come from? That's the token we're grabbing out of this path right here. So Firebase automatically gives us this as part of our authorization or our authentication with Firebase. And then we have this as part of our path. Now I realized I mistakenly duplicated allow read write if, so let me just do a little bit of housekeeping here. And then let's go ahead and publish our rules. And published rules, let's redeploy, make sure everything still works. The initial signs look promising. We notice that we do still have our flowering cherry that we created earlier. And we can try and create a new specimen. Say Western Red Cedar, Avondale Community Garden. Description, beautiful old tree. Date planted, 1966. What the heck? And then we'll choose save. I let it run through our breakpoints, and we see that after it did that, our drop-down automatically updated with this Western Red Cedar. And if we go back to Firebase, we choose data, users, and actually at this point I can delete the old specimens collection, but we go to the users at root, we go to my user record, we go to our collection, and we see now we have 2 specimens under my user directory. We have our flowering cherry we created at first, and then we have the Western Red Cedar that we just updated. Ta-da! So in this video we've seen how to create protected user directories in Firebase Database or Firebase Cloud Firestore so that we can segment off user data and give authenticated users access to only their information, and non-authenticated users get access to no information. As always, I hope this video was helpful, and I look forward to reading your comments. Thank you.